Okay, good morning, everyone. In today's class, we review some experience with Python. Last class, we just started to have some feelings, and hopefully by now, you already installed Hadoop Hortonworks on your system. Hadoop sandbox for Horton sandbox for Hadoop. Today, we do our first Python experiment using Horton sandbox, and we are using for just having an experience of how MapReduce works over Python. We are using the version 2 of Python because it has the most stable one in Horton sandbox. Later in Amazon AWS and other platforms, we are using the latest version of Python Hadoop ecosystems. Any questions from the previous session? Okay, if there is no question, let me just go to our first experiment. So we want to find distribution of ratings in the movie lens dataset that you already reviewed in the previous class. And we want to do over MapReduce methodology. So does anyone remember what does map means in MapReduce? Okay, what does this function do? But it's like, for example, for I, URI are different URI features, add event to, I don't know, either one URI to you're almost right. Basically, the only point of doing Hadoop MapReduce is doing parallel processing. Using parallel computing nodes. So, and also we know that some nodes might suddenly shut down and we lose them. So what we do, we do exact same copy of our data on several nodes. And when we do parallel processing, in each node, we just focus on a portion of our data. And in each node, we do a process on a part of our all of data set. So when you have several computing nodes, you do several computing at the same time on different section of your data. Like here, in this problem, we want to find the distribution of ratings. What does it mean? What does distribution of rating means? For example, how many times rating of 3 repeated, how many times repeat of 1, 2, or 0, or 5. So first of all, only rating columns is needed because we just want to count how many times 3, 1, 2, 4, 5 repeated. So the other columns are extra. We don't need those information. And the first part is just mapping. So the first 2 records are 3, and we have 3 computing nodes. In the first node, we just say focus on the first 3 and second 3, or first record and second record, that both of them are 3. And we assign number 1 here because we use it later. There's no reason for that because we just need it later. Then third and fourth row are rating of 1 and 2, and each of them repeated 1 time. So instead of in front of 1, we have 1, in front of 2, we have 1. And the last 2 records are 1 and 4, and for each of them, we assign number 1. The next step is shuffle and sort. So the key parameter here is the rating number. So we do sorting based on key value, or based on the key parameter, which is rating. So for example, every rating 1 in one location, all of rating 2 in one location, 3, 4. So we just sort them based on the rating value. Having said that, in the first part, we have rating of 1. So 1 happened here and here. So we have two ones in front of one. Rating of 2 just happened one time. So we have 2 here. Rating of 3 repeated twice. So there's 2 ones in front of 3. And rating of 4 just repeated one time. So I have 1 here. So just sorting based on the key parameter. Again, key parameters is the parameter that identify each records. The last part is reducing or aggregation. So we just sum up 1 plus 1, so 2. Rating of 2 just repeated one time, so 1. Rating of 3 repeated twice, so 1 plus 1, 2. And rating of 4 just repeated one time, so it's in front of 4 we have 1. So now you can find the reason that we put 1 here, because later we just want to sum up the ones to see how many times rating of 2, 4, 3, or 1 repeated. Yes? We don't need it. This problem is finding distribution of ratings. We don't want to. Maybe later in other problem we look at movie ID, user ID, but here is that we are not interested to do that. So it's about calculation. Yeah, we just want to calculate how many ratings of 3, 1, 2, and 4 repeated. Okay, very good. So as you see here, we have, first of all, we import mrjob package, which stands for MapReduce job. Then we have a default part that I define a class of mrjob, which is rating histogram. Is an arbitrary name. You can just put any name that you like. We're just saying we are making a class instance of that package. In that package, we need to identify what is our mapper function and what is our reducer function. So self.mapper underline rating and self underline reducer rating just refers to our mapper and reducer function that we need to define later. Then in the mapper part, we just said take the input, so each line, and split based on any tab that you see. If I go here, there is 196, then tab 242, then tab 3, then tab timestamp. Then next line, 2. Tab means like something like space between the values. So it's a text input. It's the only way that Python understands which numbers belongs to which column is based on the format that is like separated based on tab. So as you see, each line would be split based on tab. And as you see here in the yield part, we just interested in the rating column. And we also we export or yield number of 1. So it's actually what happens here. So each rating number 1, each rating number 1. So it's just showing what happens in the mapping section. In the reducer section, these outcomes come here. The first outcome or first outcome is a key parameter. The second yield or outcome is a value parameter. As you see here, when it just reduce, it reduced based on the key, which is rating, and it yields the summation of all of the ones. So if you have 3 1, for rating of 2, just repeat it 3 times, the outcome would be 2, 1 plus 1 plus 1, 3. So let's do that. I mean, there is 2 ways. I mean, more than 2 ways actually. You already downloaded the u.data from GitHub in the previous class, but you know this is a free service. it happened in your previous class, when all of your friends download it, GitHub even didn't let me to download from my own GitHub. So when so many people are using at the same time, it's a free service, we might have an issue. One of your friends proposed a way that you can connect your local system to Hadoop. I tried next time. He introduced using a software to connecting. But anyway, please try to see if you can download. If you can, it gives you some error. It just means this free service doesn't allow everyone to download at the same time. You can try it later. And I upload the video. So let me just connect over my PuTTY. Oh, I give you like 4 or 5 minutes because you cannot run PuTTY as it is. First, you need to, let me just show. First, you need to run your virtual Dropbox. And then after you see this window, you can run PuTTY or using your your terminal in the Mac. So I give you like 3-4 minutes so everyone run the virtual box. And if you're a Windows user, you can connect through PuTTY. Again, if you run your virtual box is too slow, you need to increase your RAM. If your system RAM is limited, it might take more time to load your virtual box. But at the end of this class, I show you how to install Hadoop directly on your system. So it could be much faster, actually. As I said, this is for just experiencing or doing some experiment with MapReduce. Later, we use Amazon AWS, which you work with the actual Hadoop and Spark environments. But these are for learning purposes and see how a MapReduce function works. And it's the reason I'm trying to use the one that is the most stable, has the less amount of errors, because otherwise we should spend whole of semester finding the errors in your systems. So hopefully by now all of you get to run the VirtualBox through PuTTY. Now I'm connecting to my VirtualBox Hadoop environment. So let me share with your friends. Now, first I want to download the u.data, which has the rating database, movie lens database. So I just type wget space the address. I think I cannot download it because it should be much faster than this. Let's see. Yep. Again, for some of you even could download from my GitHub, I couldn't. So then same for here. You can download rating MR, which is just exactly this code here. wget. Yeah, still I cannot get that. Yep, no worries. So assuming that if you get same error that I'm getting, is you just download the file later. You use just wget function, then you put the link address and you get the like file and the Python code. Having said that, hopefully you are able to download it. And also I put the files over your Moodle. And I'm trying one of your friend's suggestions. So if you could, maybe we can transfer data even without GitHub. So that save a lot of time. It could be easier. But anyway, so there is two ways that you can run your code. One of them is locally using your local system. Another one using Hadoop. Here, our data set is very small, but in the real cases, when in the industry, you can try your code over a sample data set, which is much less than the actual one. If you don't get any error, you can then run your code over Hadoop ecosystem. So for this experiment, both of them are fast, but in actual cases, when we locally we just run over a small sample of data, but over Hadoop we run over whole data set because we do parallel processing, which is much faster. So having said that, let me just run it locally. You can type the code or just copy and paste from PowerPoint. Let me just show you. So you just copy, right click. Okay, so in the previous class, I edited the code. So just let me just make the code back. So I'll show you. Rating.py. Okay, let me run it again. So as you see, for rating of 1, it happened like 6,000 times something. Rating to 11,000 times, and last rating, which is 5, happened 21,203. So it means people are very nice in rating. Many ratings are 5 and 4. 3 also is 27,000. So now, if I want to run over Hadoop ecosystem, let's say now I want to work with the actual data. I just do same thing, Python code. So this part is locally, but the data part is over Hadoop. So as you see, I said dash Hadoop streaming jar, and this is the address of file and Hadoop ecosystem. So again, if you want to run over Hadoop ecosystem, copy, paste into your terminal. And the same result, but this time we used Hadoop ecosystem. So this time it run in the parallel. Again, yes? You didn't? I mean, uh-huh. Okay. Okay, first, we use local system. That's fine. Second part, now we want to ask Hadoop ecosystem to run it in parallel. So we need to identify the streaming file. A streaming file means the file that let Hadoop to do in parallel. This is Hadoop dash streaming jar. This part is just the address of Hadoop. You can assume Hadoop ecosystem file, and also u.data is over Hadoop too. So basically, this part just saying run the code in parallel using Hadoop ecosystem. And both of them are fast because our data set is small, and again, it's for learning purposes, but actually your data could be much larger than this. So is there any question for the people, even the people who are over Zoom? If you are looking at course over Zoom, you can ask your question by typing, or even you can use your microphone. Okay, one of your friend has a question. Oh, no question. Okay, now I want to see how many times a movie rated. So last time I look at histogram or distribution of rating column. Now I need to look at the distribution of movie ID column. It just shows how many times a specific ID that related to a movie repeated. So very easy. This time, instead of rating column, we just focus on the movie ID column, because we want to count or find how many times a movie rated. So what can we do? Still, I made a Python code for that. Or you can edit the previous Python code over Hadoop. Over Horton Sandbox. But it's not the way that we recommend, because Python is sensitive. Even if you have a space problem, a space issue, Python gives you error. So the better way of working with that is just using a professional editor like Jupyter of Anaconda or other Python editors. So it avoids a lot of error for you. Much easier to edit over those softwares. But if you remember last time, we installed Nano, which is a simple text editor for, that you can use, which is, again, it's not recommended. Here, the edit is very easy because we just want to change rating to movie ID and count how many times the movie ID repeated. But let's me to do that. So I type nano rating MR, and I can press tab. So, oh no, I think it's not new. So anyway, pi. So rating MR pi. So this is the previous code. Instead of rating here, I can change it to movie ID. Then I need to save it. I press Ctrl X. Now I'm just saying that do you want save, and press Y. And I can change the file name here. If I don't change the name here, it will be saved with the previous Python code name. Otherwise, let me just put rating MR. Maybe I can change it to movie MR. But I think I already have that file in my system. Yeah. Yes. So this time, Python moviemr.py u.dat. So as you see on the left column, I have movie IDs. On the right column, how many times that they are repeated. So this challenge was not difficult. We just, instead of rating, focus on the rating column, we focus on the movie ID column. And you can do the same. You can use Hadoop Ecosystem to run it in parallel. Let me just go back to Nano again. So let's say you cannot download the file, you can write it in Scratch. So just type nano, let's say test.py, enter. Now you have an empty text editor or empty like text document. You can just say, type your Python code, just put like, here is my code. Or whatever code you can just type in each line. And then with Ctrl X, you just, do you want to save? Yes. And even instead of test.py, you can put a new name or press enter, so it's rerouted. So again, you can use Nano text editor, but it's not what I recommend, because even with a small typo, you get some error that you cannot understand what is going on. So it's better to just use a better text editor out of command prompts. So you're much, it's much more efficient for you. Okay, let's look at the outcome. First of all, let's look at the left column. As you see, it seems sorted, but not in a nice way. Look at here. We have, maybe here, 500. Let me just show it here. 599. So after 599, you expect it should be 600, but just put 6, then 60, then 600. So what does it mean? It's in the reduce, it's sorted for you, but sorted not based on numerical value, based on their string value. Because one of the thing in MapReduce, it just assumes the input and output is kind of string. So is a string wise 6 is before 60? Because is SIX 60 is SIX TY, and so it's not, it's actually sorted, but based on movie ID, even it's not in the very nice, the best way that we expect. So what happens if you want to sort based on how many times a movie rated, based on the right column? Yeah. So we need two things. One way, just switch the right and left column. So when you switch the input of the reduce, instead of key, you put the count. Instead of value, you put the movie ID. When it wants to sort, now it's sort based on the right column. So if you just switch inputs parameters, it could be sorted, but it would sort based on string value. So we need to do two things. First of all, for sorting for based on how many times the movie rated, input should be switched. Also, you need to let Python knows that the right column is has a numerical value. It's not string. So again, for sorting based on how many times the movie rated, two things. Using the sorting option of MapReduce, also letting MapReduce knows that the right column here has a numerical value. It's not just a string. What can we do? First of all, we introduce second reducer. And the only point of second reducer is just for switching the left and right column, nothing more. And also looping through the values to show all of the sorted values. And for them, also we need to introduce second change, which is letting MapReduce knows that those has numerical values. What can we do for, there's two ways for letting Python knows the right column has a numerical value. One way is through JSON files. In JSON, you can keep the numerical format, introduce it to MapReduce functions. And the one is just zero padding. Zero padding, there is no mathematical formula for zero padding. It's just a creative way to let Python know those values has numerical, those has numerical values. For example, 4 with zero pad with 5 zeros. So it just means you when you want to rewrite it, start from right side. 4 just take 1 0, 80 takes 2 digits. So 2 of those zeros change to 80. If you want to put 199, 3 digits would be changed to numbers and 2 would be 0. So we do zero padding. Again, there is nothing here, just letting Python MapReduce knows that the like 004 or 0080 has a numerical value. Might look be strange, but it's one of the ways that we later we introduce JSON. In JSON, it's easy, just say it has a numerical value and that's it. But it's just a kind of creative way of doing that. So as you see here, we just say use sum ones for avoiding any error. We just say it's a string, but do zero padding and the key values. And let me just go over here. Also in the second one, as you see, the first input here is not movie ID, is count. So now Python MapReduce think the first one is the one that it should be sorted. If you look at the previous MapReduce, here, the first value is key here is movie ID. When it does sorting, it sorts based on movie ID. This time, when we do summation, it just assume count is basically is your, we just do a trick. It just assume now the first parameter is key that should be sorted. And we do a for loop to just show all of them. Let me show it here. So again, same as before, I also put this code over Moodle and GitHub. You can download it. Let's just run one of those, either Python or Hadoop. So let me just copy here. Paste. Look at here. Now it's sorted based on how many times a movie rated. And as you see, the lowest rating is 1. Some of the movies just rated 1 time. And the highest is rating for here, which is 584 times this movie ID 50 is rated. Again, we did 2 things. First of all, switching count and movie ID. So the sorting would be based on count. The second one, zero padding. So Python MapReduce deal with it as a numerical, that as something that has a numerical value. Movie. Okay. So look at here. I just opened through Nano. Let me just check if people in the Zoom can see. So the first reducer has two outcomes: counts, zero padded counts, and key, which is movie ID. As you see, you don't have to put key and values. These are arbitrary names. Python MapReduce thinks the first parameter is ID or key value. The second is value. So although in the first MapReduce I put key and values, but you can put any names. For better understanding of ourselves, I just put key and values, but these are again arbitrary names. As you see, it goes to the second reducer function. This numerical value here, first parameter. Key, second parameter. So this time, when it does sorting, it sorts based on the first parameter, which was count. But if I don't do this, let's say I don't have this function here, and I just have one reducer, this time it just sorts based on key, which is movie ID. So we didn't like that. We didn't want to sort based on movie ID. We wanted to sort based on count. So we have to define a second reducer to just switch the first and second column. Because in the yield of first reducer, we already switched them. So first parameter is count, key, second reducer think the first one is key that should be sorted. So it's the reason in the second part, the values are sorted based on count. But you need to just play with that. It might be a little confusing, but look at the outcome. Again, when I wanted to yield, I switched first and second. I didn't. It just for showing purposes. You don't. Here, instead of yield movie count, you can just put count movie. It's not very important. You just need to know when reducer get an input, the output of the reducer would be sorted based on the first input. I know it could be a little challenging, difficult. So any questions? It might sound a little difficult first time because your first time you expose yourself to this, but if you play a little bit, it makes a lot of sense. So if you are over Zoom, you have question? You cannot run your Hadoop? Let me see. The pattern we use in Hadoop is 2.7. Yes, this one, because it has, just for experimentation, is a little different from, yeah, it's just for understanding MapReduce. Just that there is a typo in your code. Yeah, it just told me there is a typo. So type W here, WG, space. So you cannot download. Now it's there. Oh, we need to download the user that we need to download the brand. Now you have to do that. You have used which Python have? Oh, you didn't install MRJ with previous lab. You need to go to previous lab and install MRJ. You didn't install that package, so you cannot run it. Yes. You can use 2.5 or version 3, but you need to do a little changes when you do installations. Which version you use? Yeah, that's a little different. I think you need, when you install Python or MRJ, it should be a little different. So let me find the documentation and send it to you. But this is like 2.65. Okay, so here I go to your second assignment. In second assignment, you need to find 5 top users that has a higher rating. Maybe what does it mean average highest rating? It just means, or highest average of rating means, let's say there is like 100 users that the average of ratings are 4 or 5. Just show me 5 of them. You don't have to just show me all of those 100. Just as an example, we have 3 users of 22, 0, and 196. They have ratings of 1, 2, 3, and 5. For user 22, I just focus on the rating column. 5 plus 2 divided by 3 equal 4. So this is average of 22. Average of 0 is 3 plus 3 divided 2, 3. And for 196, it's just 1 plus 2 divided by 2, 1.5. So having said that, average of each use, if I want to sort based on the averages, 196 has average of 1.5, 0 has average of 3, and 22 has average of 4. And so 22 has the highest average, which is 4. But when you do coding, maybe 100 of them has average of 4. Just show me 5 of them. That's fine. There is 2 ways. One way, probably you can make 2 Python files. One of them, you count how many times a user rated. And in the second Python code, maybe you can find summation of all of ratings by one user. And maybe just pick some of them, do the calculation by your calculator, and just tell me these 5 users had the highest rating. Another one, which is not too difficult, but you can also Google it. I mean, you probably can find it somewhere. You can just make one Python code that do the average and then sort the users based on the average of rating. If you just do one Python code, you get a bonus, but because I haven't taught it yet, but you can just, you can use the knowledge of this session and just make 2 Python codes. In one of them, you just sum up the ratings. In the second one, for each user, you just assign number of 1, like the first problem that I showed. So if you assign number 1 for each user ID, when you sum up, summation of 1s just tell you how many times that user did rating. In the second Python code, you do summation of users plus actual ratings. So instead of putting 1, you put the actual rating there. And when you do sum, it just show you summation of all of the ratings. Let's say for user 22, the summation of ratings 100, and how many times that he rated is, let's say he rated 25 times. So now you have 2 outcomes from 2 different Python code. You use your calculator, it says 100 divided by 25. So his average rating is 4. Another one, you can just make a one Python code that does everything for you. Again, since the Python MapReduce thing, the input is string, and again, you want in that way, when you want to sum up the ratings, you need use this function, sum parentheses int rating. So now when it does rating, now I understand the rating is actually integer number. So it can just sum up all of those ratings. It shouldn't be very difficult. Again, even you can Google and find something similar, but again, you get a bonus if you just do one Python code. So you don't have to, you can simply do 2 different Python codes and use your calculator finding the highest average, 5 of users that had highest average of ratings. Any questions?
Everything in one function?
Not one function, one Python code. You can, in one Python code, you can have 3 reducers. That's fine. Any number of reducers that you can. But for making one Python code, you need to do some extra thing by just Googling how to find average, how to do that. And so it's the reason I give you bonus, but no worries. With today's knowledge, you can make 2 different Python codes. One, you count how many times the user rated. Another one, you sum up all of the ratings with this function because you want to avoid errors. And just use your calculator and report it. Also, I put the solution how to install Hadoop 3.3 directly in your system. First of all, you need to remove Java. Sometimes Java gives error, so you need to make like some 2 folders of Java JDK and Java JRE in your C drive. And when you do installation, install inside those functions. Sorry, inside those folders. Then you download Hadoop, Apache Hadoop, and then you unzip it. And you need to put it in a Hadoop folder under your C drive. Also, you need to change what is inside your bin folder. You can get to this GitHub and just replace whatever you downloaded with the Hadoop/bin folder. I also put this GitHub over Moodle. So in your Moodle, you have what should be inside your bin folder and replace it with your Hadoop instance that you installed. You need to change, add some addresses here in your environment variables, and also change your path variable. Put your Java and Hadoop addresses here. One more important, whenever you use command prompt, sometimes you get some error. It's better to open it as an administrator. I'm just skimming through the solution because we don't have that much of time. Another thing, you need to run WinUtils. It's important. What else you can make errors? So, okay, the last part, you need to change some configuration. So inside Hadoop etc Hadoop folder, there is like course side XML that you need to just put this one completely. Also, you need to make a data folder over your C drive and also put this one here. So you need to create a data folder too under C drive, change this configuration of HDFS site, change another configuration from MapReduce site. And also the last one is this one, yarn site XML. Then you need to format your name node command in the CMD. Don't forget that your CMD should be in administrative, with administrative user. Then let me just go to the end. If you do everything, anytime you can just go to your command prompt. Let's go to the CMD. I run it as administrator. In the last class, I did some changes. Hopefully, it doesn't give me any error. So start yarn. Okay. It should be much faster than your virtual drive. And let me just copy and paste this at local address. Let me show it here. Local address 8088. And now I have Hadoop directly on my system. Later, I just type, for shutting down, I just type stop -yarn. I just stop my Hadoop. So if you have some RAM issues, probably if you install your Hadoop and Spark environments directly, it's much faster and needs less amount of RAM from your system. Any questions? So if you guys over Zoom, you can use microphone or just type your questions if you have. So for the next class, please try that MapReduce Python experiment. I mean, finding the 5 of top users. As I said, it might be 100 users with the highest average, but just show me 5 of them. You can Google it and see how you can find average and then sort just within one Python code and get a bonus. Otherwise, as I said, 2 Python code. One, for each user, you assign number 1, like the first problem that I had, sum them up. So you can find how many times a user rated. In the second Python code, when you do summation, you sum based on user ID and sum of rating column. So instead of 1, you need to put the rating. And since rating is a string, you put rating within int parentheses. So int parentheses rating. And then you sum it up. And you also have seen how to sort with the two MapReduce. So again, today class is the most important thing that you understand that when you want to do extra thing, maybe you can just add more reducer with multiple thing. Also, just your first Python experiment might be a little challenging, but when you practice it, it's not too difficult. I mean, first time might be horrifying, but it's just a learning curve associated with that. And again, this is a difficult content that I know. I was a student, I learned that, so no worries. I understand that might be a little difficult, especially installation might be horrifying. You might get some random error from different ways, but I understand that. So I understand this is a really difficult course. No worries. Any question? Cool. So if there's no question, let me just stop recording. And again, you have issues, just let me know. And just expose yourself more and more to this content. You know, maybe like 5 years ago, machine learning was a very wow thing in your resume. Still, machine learning and data science is a hot topic, but so many people learn that. But like MapReduce is very new and difficult. So there's not that much of people who knows that. So you just spend more and more on time. I mean, I know it's like sometimes when you get errors, it's just a headache for you, but it's the way that you learn. And later, when you put in your resume that you can do machine learning using MapReduce or MapReduce programmer, or Hadoop programmer, is very shining, but it's not too much of people can do that. Cool. Thank you very much, and have a great rest of the day.